Okay, so we're told the probability distribution of the discrete random variable x is given by the following table. Notice that in this table we have a probability for 1 is equal to k and a probability that for 4 is equal to 0.4 minus k. It says here to state the range of values of the constant k. Well, for this we need to really go back to our original definition of probability. We know that any probability must be between 0 and 1. It can't be negative and it can't be greater than 1 because 1 is certain and 0 is impossible. Okay, so that means the smallest possible value here is that k must be at the very least equal to 0. So 0 is less than or equal to k. If we focus on this value here, what we then know is that k can be anything from 0 up to 0.4, so that we get 0.4 minus 0.4 is 0, but it can't be any bigger than 0.4 because if I do, it makes the probability for this value here a negative value. So simply the range of values for k is between 0 and not 0 and 4, apologies, that should be 0 and 0.4 of course. Okay, and that is all that you need to do for that first question. Okay, part B asks for the range of values for the expectation of x. Easiest way to do this, because this is going to help you with the next part of the question, although you wouldn't notice at the moment, is to work out the expectation of x in terms of an expression. And what I mean by this is just to work it out using k as your probability. So as always with the expectation of x, show the summation of your probabilities and x values multiplied together. So 1 times k, 2 times 0.1 plus 3 times 0.2 plus, remember with this one, we're still going to use 0.4 minus k. We're going to get an expression and then plus 5 times 0.3. Now, when you work through this, when you expand this, what you'll find is that you get an expression which simplifies to give us that the expectation of x is 3.9 minus 3k. So there's nothing new, unusual or difficult about this. You just have to expand, carry out those multiplications, carry out the summation, and it will simplify finally to give you this expression here for the expectation of x. Then to finally answer the question, the range of values for e of x, then what we need to do is just imagine what happens if k is equal to 0 and what happens if k is equal to 0.4. Now if k is equal to 0, that will give us our maximum expectation. So if we put in k equals 0.4, 3.9, take away 3 lots of 0.4, and actually what we can do is let's write it down. So 3.9 minus 3 lots of 0.4 will be less than or equal to expectation of x less than or equal to 3.9 minus 3 lots of 0. Okay, and this leads us to actually get the range that expectation of x lies between 2.7 and 3.9. Okay, now it will work if you actually just put in k is equal to 0 and calculate the expectation of x, and k is equal to 0.4 and get the expectation of x. What you are expected to give is this range. It is a range of values. It's not simply that it can be 2.7 or it can be 3.9. It lies between this range. And also in a moment you're going to see how we're going to use this to answer part C. Okay, part C is a fairly tricky question, but you just have to follow your instincts on this and go through the process, and it's 8 marks, so just work out whatever you can to get whatever marks you can, and as you get closer you might surprise yourself and find that you're actually going to get the solution here. So we're told, given that the variance of x is equal to 1.5 determine the value of k. What I know is, to find the variance of x, I need to know the expectation of x and the expectation of x squared. I know the expectation of x, so let's find out the expectation of x squared. And it's exactly the same as I did before, except I'm going to square all my x values, so 1 squared times k, plus 2 squared times k, times the probability, so 0.1, sorry, 3 squared, and just as I've given tips before, I'm writing out that whole line for expectation of x exactly the same, except I'm squaring each one of the x values, not the probabilities, and I'm just going to carry out that sum just as before, so 5 squared times 0.3. When you go through the process of expanding and simplifying this again, what you'll find is you get an expression which is 16.1 minus 15k. Okay, now at this point we've got two expressions, one for e of x, I've missed out the expectation x squared there, so just squeeze it there, apologies, and for e of x squared. So remember that the variance of x is equal to e of x squared minus the expectation of x, and we square that expectation. So what I'm going to do is I'm going to take the expression for e of x squared, 16.1 minus 15k, and I'm going to take away the expression 3.9 minus 3k. Oops, not sure what happened there, apologies. Let's take this back a second. Okay, so we're going to take away the expression for the expectation of x squared. Please remember when you deal with this bracket, it is not simply squaring the 3.9 and squaring the 3 minus 3k. Remember that you are supposed to multiply this bracket by itself. So we're going to come out with an expression. It doesn't look particularly nice at first. So we're going to have 16.1. Actually 16.1 minus 15k. Just while I remember at this point, instead of writing the variance of x, what I'm going to do is I'm going to put in this variance of x value 1.5. So actually I'm setting up an equation. So this variance of x 1.5 is going to be equal to 16.1 minus 15k. Take away, when I expand that bracket, I get 15.21 from the 3.9 times 3.9. I get two lots of 3 times 3.9k. So I then get minus 23.4k. And then I get plus 9k squared. And so if I tidy this all up, I get 1.5 is equal to 16.1 take away the 15.21 gives me 0.89. Minus 15, I'm going to get minus 23.4, so it actually becomes a plus. So I get minus 15 plus 23.4k gives me plus 8.4k. And then I get minus the 9k. 9k squared, sorry. At this point you can see I've got a quadratic, so I'm just going to rearrange the quadratic so that I've got positive 9 squared. So I'm going to have positive 9k squared. I'm going to have negative 8.4k. And then I'm going to do 1.5, take away the 0.89, which leaves me with 0.61. And that is equal to 0. Okay, so at this point, having rearranged, basically I've added 9k squared to both sides, I've subtracted the 8.4k from both sides, and I've subtracted 0.89 from both sides. And all I've done is, then written that out here. Now I've got a quadratic here. This doesn't look like it's going to factorize, so what we're going to have to do is we're going to have to use the quadratic formula to solve this. And so remember that the quadratic formula we're just going to say it's k instead. It's minus b plus minus the square root of b squared minus 4ac all over 2a. So just take your time using this. Okay, just because we're doing a statistics exam doesn't mean that you forget your core maths methods. Remember, show exactly how you substitute it in. Don't do any mental arithmetic. Don't start to do partial calculations along the way. Just show the substitution and then put it into your calculator and evaluate it. Okay, you should be able to use your calculator effectively, so you can type something as complex as this in one go and be confident that you're going to get the right answer. So we've got the minus b plus or minus the b squared minus 4 times a, which is 9, times c, which is 0.61. Just going to extend that square root so it goes all the way over the top. This is all the way over 2 lots of a, which is 2 lots of 9. Now, when you type this into your calculator, take care when you do the minus b plus the square root. Our first solution should come out as 0.85 to 2 decimal places. And then when you do the second solution, so the minus b minus the square root, you should get that k is equal to 0.08 to 2 decimal places. Okay, so marks are getting to this point. Just a final note at this point, we shouldn't really have 2 solutions. In terms of a quadratic, yes, we are expecting 2 solutions, but only one of these apply to the question that we're doing at the moment. And so how do I determine that? Well, if we go back to my original range, what I know is that k must lie between 0 and 0.4. So just a final statement, and your final mark is given for this, and you lose this mark if you don't get it. Therefore, k equals 0.08, since 0 must be less than or equal to k, less than or equal to 0.4. And there is a mark for that statement. It's something communicating effectively how you've picked the correct solution from this. Okay, so let's just have a quick look at see how the marks were awarded in this question. Apologies, let's just change the colour of my pen there. Okay, so question 1. Question 1's nice and straightforward. Okay, so question 1, you're just given 1 mark for identifying a correct range. In part B, 3 marks awarded. 1 mark is awarded for the correct calculation here, so that is your summation. 1 mark is awarded if you've got an expression for the expectation of x as 3.9 minus 3k, and 1 mark is awarded if you've then given this range 2.7 less than or equal to x less than or equal to 3.9. Now, question C has 8 marks. As I said, it's got lots of marks, and as I said, if you just work through and just do bits and pieces that you can still pick up considerable amount, even if you wasn't confident enough to work all the way down to the bottom. First mark, as before, the first mark is given. Expectation of x squared, showing the full calculation for working out the expectation of x squared. 1 mark is then given for a correct expression for the variance. Sorry, not the variance, for the expectation of x squared. Next, working down, you can have 1 mark if you've got the expression, the variance of x is equal to 16.1 minus 15k minus 3.9k squared. Your next mark is then given for correctly expanding and using this 1.5 value in here as well, and setting up and finally getting to this equation here where we found that 9k squared minus 8k plus 0.61 is equal to 0. Okay, so that was 1 mark for setting up the variance equation, and that is 1 mark for actually correctly expanding and simplifying to get this quadratic equation here. 1 mark is then given for the correct substitution into the quadratic formula, so demonstrating that you understood that you had to use a quadratic formula and are able to use a quadratic formula. 1 mark is then given for each of the potential values of k down the bottom here, so k is equal to 0.85 or 0.08. Must be accurate answers rounded to 2 decimal places. If your answer rounds to 2 decimal places, you can award yourself that. And then finally, as I said, you get 1 mark if you have communicated effectively that k is equal to 0.08, because it lies in this range. All of these then add up to give you a total of 12 marks. Excellent. I hope you understood that all.